Hello everyone, thanks so much for joining us today to learn about Cloudflare's SSL for SaaS providers solution, fully managed HTTPS for custom vanity domains. For today's agenda, we're going to be reviewing housekeeping for the webinar, an overview of Cloudflare, an overview of SSL for SaaS, a quick product demo, and a Q&A session. So speaking today, my name is Brady Gentile. I'm a product marketing manager here at Cloudflare.
And I'm Patrick Donahue. I've been on the product management team at Cloudflare for 2.5 years. My team builds all of our customer-facing HTTPS services, including Universal SSL, which provides free certificates for our 6 million plus websites. Additionally, we're responsible for Cloudflare's Origin CA, dedicated certificates, and of course the product we're going to talk to you about today, SSL for SaaS.
So to go over a few housekeeping items, please stay to the end of the presentation to receive slides, a recording, and some resources. Ask questions in the questions chat box and ReadyTalk on the bottom left side of your screen. We're going to triage all questions at the end of the presentation, and remember, all attendees are muted. So most everyone on this call is familiar with Cloudflare, but we'd like to give you a really brief overview of Cloudflare before we dive into learning more about the SSL for SaaS solution. Cloudflare's global Anycast network consists of 116 data centers and growing over 57 countries. We serve 10% of the world's internet requests every day, amounting to over 5 million requests per second. And our network speeds up these requests by over 2 times. Cloudflare has over 6 million websites, applications, and APIs on its network, with 2.5 billion monthly active users accessing those assets, generating over 1.3 trillion page views. So Cloudflare was built from the ground up as a security company, offering DDoS protection, web application firewall, SSL, secure registrar, rate limiting, and more. And most people know Cloudflare for our DDoS protection capabilities. We've defended some of the largest attacks ever recorded and have 10 terabits per second of DDoS capacity. We protect against attacks targeting layers 3 through 7 of websites and APIs, as well as the DNS infrastructure. And a side note, all of Cloudflare's capabilities, including those listed on this slide and the next, are extended to your end customers through our SSL for SaaS solution, which we'll get to in just a minute here. Moving on to performance, Cloudflare speeds up internet assets by over 2x through its content delivery network, website optimizations, DNS, SSL, load balancing, and Argo smart routing. We've built one of the largest networks in the world and peer at more internet exchange points globally than any other CDN provider out there. So to dive into our SSL for SaaS solution, on this slide you're going to see 3 common sets of challenges that SaaS providers face when their services are generating public-facing assets for end customers. So in the first scenario here, you'll see we have an unencrypted but branded vanity domain. So you'll see from the URL bar in this scenario that the customer was able to CNAME their domain to the SaaS provider and is using their own custom URL, support.customer.com. But unfortunately, it's unencrypted. And so the upside is that the domain is branded, and the downside is that the website doesn't have HTTPS. So custom vanity domains without HTTPS, they end up lacking the performance benefits of SSL and the secure data transfer of SSL. They're vulnerable to snooping and content being modified or injected before reaching visitors. And in addition to those downsides, modern web browsers today, including Google Chrome and Firefox, are beginning to show prominent warnings to website visitors that the website's untrusted and not safe to be visiting. In the second scenario, encrypted but unbranded vanity domains, this one, the end customers have encryption, but they're using a subdomain of the SaaS provider's domain for their web assets. So you'll see that's listed as the end customer's name.saasprovidersname.com in the URL bar. And although this scenario does offer the benefits of HTTPS between end customers and their visitors, the subdomain lacks proper branding. And this is going to result in a lower level of visitor trust and degraded SEO rankings. The third option here, a scenario that a SaaS provider might find themselves in, is the challenging in-house approach. And in this scenario, SaaS providers whose customers require branded vanity domains and encryption had to either manually manage the SSL lifecycle for their customers, which results in really long deployment times and overhead costs and manual effort, or they have to build their own complex automated in-house solution, which requires a lot of engineering effort. But both of these scenarios place a huge burden on both the SaaS provider and their end customer. And we'll dive into a little bit more about that right now.
So as Brady mentioned on the last slide, we speak to quite a few customers who are either contemplating deploying HTTPS for custom domains themselves or have already done so and are struggling to scale their processes and systems. Typically, these companies start out by supporting plain text HTTP, instructing their end customers to CNAME their custom domains over, and then serving traffic based on the incoming host header. Besides the inherent problems with this setup, namely lack of confidentiality, integrity, authentication, we're hearing from SaaS providers that their customers are asking about HTTPS support more and more frequently. So in some cases, these customers want to be able to upload their own certs, which we support, but for the most part, they want the provider to handle the entire process for them. In terms of actually deciding to deploy HTTPS, our SaaS customers are typically aware of the benefits it provides, in particular enabling HTTP2, encryption, etc. And this, along with the fact that their competitors are doing it, is what seems to be driving them towards implementing a solution. Once a decision has been made to use SSL, where we typically see providers start is by designing a process where their support personnel can work with customers to manually acquire certificates and private keys. This process is often difficult for their customers. Just getting that initial CNAME pointed is friction enough typically, but also depending on the CA, it can be expensive too. Once the certificates have been passed along to the SaaS provider, hopefully in some secure fashion, they're typically just thrown unencrypted on disk, and then web servers are restarted by hand. After this initial manual process has been established for uploading certs, the next thing that companies realize they need to do is figure out how to handle renewals. The hope is that customers are able to renew these certs in time, perhaps nudged along by reminder emails, and also that the ops team is able to handle the re-upload, restart as the certificates trickle in. In some cases, the customers are providing certs that expire shortly after they've been sent on to the provider, especially if they're using a free CA like Let's Encrypt that will issue certs for 90 days at most. Those that have been in the space for a while will recall that you used to be able to get certs that were valid for 5 years, most recently 39 months, and as of late, it's been restricted to just over 2 years. I think it's 27 months precisely. Our belief in tracking the CAB form, which is the body that imposes these so-called baseline requirements on CAs, is that this number will be regularly lowered until it's measured in just a few months. So automation is critical here. Assuming that a renewal strategy can be implemented, the next challenge really is volume. As the number of websites being served via HTTPS grows, it quickly becomes apparent that these manual processes won't scale. At this stage, we've seen companies take one of two paths, either throw bodies at the problem or attempt to automate it themselves. The downsides and risks really of throwing bodies at the problem should be obvious, but the challenges with rolling an automated solution are somewhat less obvious. The way we typically see this play out is that a couple developers on the team will build a proof of concept integration with a provider like Let's Encrypt. They demonstrate that acquiring certificates is pretty easy, but as they progress, they quickly realize that acquiring certs is only a very small part of the lifecycle of managing them in a secure and performant fashion. The first challenge that these providers discover at this stage is how do you store these certs in keys at scale? Each time a new cert's issued, their web servers, which are hopefully distributed around the world for availability and performance reasons, need to be able to dynamically load the certs based on what the browser requests via SNI. So we call this lazy loading at Cloudflare, and it's something that we built back in 2014 for our Universal SSL product, which manages millions of websites now. The next challenge that providers face is from where will they terminate these TLS connections? Even with modern protocols such as TLS 1.2, there's still 2 round trips from the user's browser to their web server to establish a connection to your web server rather. In many cases, especially with businesses serving international customers, these round trips are noticeable. With Cloudflare, you'll get very low latency just about anywhere in the world, as well as being able to take advantage of a new product we have called Argo, which is a way to effectively route around congestion on the internet by using the knowledge that we have of connecting to various origin sites. Lastly, if someone's made it to this stage where they're able to acquire certificates, load them into their server, hopefully without restarting these web servers, the last reason that people come to us this late in the game is almost predominantly for DDoS reasons. So they've been able to build a mechanism to acquire certs, and they're terminating TLS directly on their own web servers. But what happens when someone attacks you? Either they've recently experienced an attack, or they think an attack is imminent for whatever reason, and they want to be prepared. So the risk here, of course, is one of your customers operating on their own custom domain gets attacked, and the attacker doesn't know necessarily that you are fronting that or sitting behind that domain name, and frankly, they probably don't care. They just want to knock that host name offline. So the risk here is that attack could bring down that shared infrastructure for all your customers. So this is why we're seeing a lot of players in the space start to move their existing solutions that were built in-house over to Cloudflare. So this slide talks through the process by which we acquire certificates at a high level. Let me explain it in a little bit more detail. I think it'll be helpful for understanding of the product. So there's nothing that the end user, your customer, has to do differently than they do today. And that was kind of a key component as we designed the product, where we understand the challenges from talking to customers of just getting their customers to put that initial CNAME in place. And we wanted to make sure that this product would require no additional effort. So all that has to happen once that's in place, or before, we can accept this before and monitor for when the CNAME is added, is a single either API call to us or a click in the UI. So most of the providers that have integrated with us have done so via API because they want to do it in an inline fashion. So if a customer is signing up and they're provisioning maybe a personalized site with their logo and domain, and maybe in the case of a website builder, whatever content or marketing portal, whatever content has been added, the idea is to get that customer up and running using HTTPS as fast as possible. So that API call will come into us. We'll then reach out to one of our certificate authority providers and indicate that we would like to issue certificates for that host name. They'll say, great, demonstrate that you have control of that host name for us to be able to adhere to those baseline requirements, and they'll give us a challenge token. And because we are reverse proxying that host name, i.e. it's routed through us, we can serve that token at the edge and demonstrate to the CA that we do in fact have control at the HTTP level of that host name. So we'll demonstrate that control, and then we'll request that 2 certificates be issued for the host name. And these certificates are issued exclusively for that host name. So if you inspect them, the common name is in the host name requested, as well as the sole, what's called subject alternative name, or SAN. Then the only SAN on there is that particular customer. So we'll get 2 certificates, and the reason we get 2 is one is called a SHA-2 ECDSA signature. That's the signature algorithm, and that is a key that's used, elliptic curve key, as well as an elliptic curve signature, and we'll present that to modern browsers that can take advantage of the benefits of ECC. We'll also, for compatibility reasons, we'll issue what's called a SHA-2 RSA certificate, and then this is presented at the edge based on the incoming capabilities of the browser. So if it can't support ECC, we'll fall back to RSA. So we'll acquire those certificates, we'll stick them together, and we'll push them out to our edge. At the time of this webinar, Cloudflare has, I believe, 116 POPs around the world. So that certificate will be acquired and then distributed to the edge to do that TLS termination as absolutely close to the end user as possible for performance reasons. So that whole process, from you sending us an API call or clicking in the UI, is about 60, maybe 90 seconds at most. So it's very, very fast to acquire and distribute the certs around the world. And we're finding that customers are doing this inline to improve the end user experience. Additionally, we'll handle the renewals of these certificates. So we're issuing 1-year certificates, and 30 days in advance of that expiration, we're able to automatically renew the certificates with no effort required on your end user. So as long as that CNAME is still in place, we can complete that validation and reissue and redeploy the certificates, and the user will be none the wiser. So besides renewal management, we'll handle any sort of reissue as needed. Anything related to the lifecycle, if the algorithms that need to change related to the signatures on the certificates or the private key generation, maybe as we move to a quantum or post-quantum world, we're able to handle all of that by nature of having that CNAME in place. So now we're going to look at a demo of the product. First, we're going to start out with the user interface, and then we'll take a look at the API. So I'm logged in here to the Cloudflare dashboard with one of my test domains, upandatoms.com, and I've clicked here onto the crypto tab. If I scroll down to custom hostnames, this is where you would configure the hostnames that are pointed into you via CNAME. So what we're going to start out with is a test domain that I've set up. So let's take a look at this testing one on this silly domain name I created. You can see here that this is, imagine this is the customer hostname. This would be CNAMEd into some hostname that we would establish in your account, and this would be set up to send all traffic back to your origin server by default. You could also specify a per hostname origin server if you want to shard your customers in some sort of fashion. That can also be used with our load balancing product if you want to configure a number of backends that we can route to. And you'll see here that this CNAME resolves to these 5 IPs, and these are the IPs that are assigned to your zone when you sign up. So what we can do here is we can grab this hostname. We can go into the browser, and we can confirm that, in fact, this is not a valid connection because there's a cert here, but it's actually not issued for my particular domain yet. It's the default certificate issued for that account. So if I want to actually instruct Cloudflare to go out and acquire a certificate, as we just discussed, all I have to do is put in that hostname here. We recommend leaving HTTP validation as default. This is the easy, kind of happy path that we talked through. We also, however, have additional validation methods. So if you want to pre-validate a domain, so as I mentioned, it's 60 to 90 seconds to issue the certificate. However, if the customer is coming from maybe an in-house solution that already has HTTPS, or maybe a competitor of yours that has HTTPS, sometimes we see our customers wanting to do pre-validation so that when the CNAME is added, that cert's already at the edge and there's zero downtime whatsoever. So the traffic will flow over without any delay. So in that case, you could do email validation, and we can actually brand or customize those emails that get sent to your customers with your logo, with your text, whatnot. But for purposes of demo, we'll just stick to HTTP validation. So once the hostname is in place, I click Add Custom Hostname. And what I see here is our system is indicating that the status of this hostname is pending validation. So as I mentioned before, we've gone out to the certificate authority, and we do this synchronously as you hit Add Custom Hostname before this modal pops up. And we ask the CA to go get us or to give us the token that they need to see at this particular path. And because this CNAME is already in place, or could be in advance of being in place, and as I mentioned earlier, we'll continue to monitor every 10 seconds to see if it's there, you can actually have us serve this validation token at the edge. And so the CA is going to be polling for this, and it's going to be looking for this token in response, and that's what handles the validation. So I'm going to click OK here. I can see that this is in pending validation state. There's a number of states it progresses through, from pending validation to pending issuance, pending deployment, and then active. You have the ability here, if you're very impatient, if you want to see it as it goes through, you can just click this refresh button here. And you'll see here that this is pending deployment. What this means is we've already completed validation at the certificate authority. We've already downloaded both of those certificates. So as I mentioned before, there's a SHA-2 ECDSA, which will serve as a smaller key exchange, so there's less bytes over the wire. and it's also required the SHA-2 RSA certificate. So at this point, it's taking those certificates, bundling them, putting them in our database, and then distributing it to the edge for really close termination of the end users. So I'm going to go ahead and click refresh again, click the refresh button to see if the status has moved on. And you can see here that it's active. So not sure how many seconds that was, but it was quite fast. I can show you that it's actually working by clicking back over here, and where we had an error before, we can refresh, and you can see here, I've got some firewall rules set up intentionally to test some stuff in this domain with my user agent in particular, but let's actually take a look at the certificate and see what's coming up. So you can see here that the not secure warning has disappeared. We've got green here in the browser. If we go into the security tab of Chrome and view the certificate, we can see that this was issued under the Cloudflare ECC intermediate to the testing one, so much TLS fun, the hostname we requested. That's the common name field. And if we expand the details here, we'll see that the certificate's an elliptic curve key. And from a subject alternative name perspective, you're only seeing this particular customer's hostname on there. So there's no commingling of certificates or combining customers together like some of our competitors do. Okay, terrific. So now that we've looked at the UI, I want to show you how this same process can be handled from the API. So if I switch over here, what I'm going to do is I'm going to actually make that same request for testing 2, which is a host name that you can see is also pointed in there. And if we take a look in curl, just to confirm that there's no certificate live, go ahead and make this request. Should be short enough to see. You can see here that there's a certificate problem. There's an invalid cert chain, which is the same error you were seeing in the browser before, where it was having a certificate return that didn't match that hostname. So now let's go get a certificate for this particular hostname. So here is the API call. We're going to set our hostname in this environment variable, and then we're going to make this curl call. So you can see here the same detail that you saw in the modal before. It's coming back with the pending validation state. It's coming back with the URL that we are pushing to the edge and the body that we're going to return. Additionally, there's some information here that can be used for polling reasons. So if you want to store this ID, you're welcome to do so. This identifies the hostname. There's a particular ID for the SSL configuration. There's additional configuration we can talk to you about beyond SSL. So there's a way to set, as I mentioned before, per hostname origins. Maybe there's certain things you want to enable on a per hostname basis, perhaps force somebody to HTTPS, so we can handle that. Really anything in the Cloudflare dashboard that you can configure, you can also do so via API. So it's a very flexible way to scale up host names without having to manage it through the UI. The ID, as I mentioned, can be used. So if we wanted to actually get the status, we can make a call here. So we can either append that ID to this list endpoint, or we can simply pass in the hostname. So we'll do that here. So you'll see here that this cert is already active. So this was really fast. I mentioned the 60 to 90 is kind of an upper bound. If there's certs being issued, it's actually frequently faster than that. So this certificate is now at the edge, and we'll confirm here with curl that we can see that as well. So let's make this connection. And you'll see here we no longer have that certificate error. We see that we've established a TLS 1.2 connection using a modern cipher suite. You can see here the chain of the certificate. This is the common name. This is the intermediate. We're coming back with an HTTP 200. And that's it. We're not seeing that CAPTCHA we saw before because I'm connecting with a different user agent. So I'm not triggering my test firewall rule. The user agent here is curl, as that's what we requested. And at this point, we have we've completed the process. So this is typically what our customers are doing within their onboarding system. So they're making these same calls to do it inline. Just while we're here, just want to show you one other thing on the hostnames endpoint, custom hostnames endpoint. So you can also make just a GET request without specifying a particular hostname. And what this will do is this will return all of the certs that we're aware of, or that you've asked us to issue, or actually you've asked us to take in as part of an upload. So as I mentioned before, if you have customers that want to provide their own certificates, perhaps EV, they're in e-commerce or they're in banking and they see value in having an EV cert, instead of specifying this SSL body with a method, you can actually give us a custom certificate and custom key, and that's just the PEM body of those two, the certain key, and we will take that and do the same process. We'll push it to our edge. You'll also be able to re-upload that as needed, but of course, you lose the benefit there of having us handle the renewal process for you. So that concludes the product demonstration, just to show you that it's one and the same from a UI perspective and API perspective. We can come in here and we can refresh this. We can refresh this crypto tab, and we can see that this host name I issued here is also accessible in the UI. If you'd like to remove those host names, and this is what we request from a kind of a good housekeeping perspective, if a customer churns, you can either send a delete call to that API endpoint, or you can simply come in here and delete the host name. And what that'll do is that'll send a message to our edge to pull down that certificate and remove it. So traffic will no longer be terminated using that certificate if you do in fact request that we delete the host name. So just to rehash the benefits of the product, we'll examine it from the end customer perspective as well as from the SaaS provider perspective. So the end customer perspective is pretty clear and obvious. First and foremost, it's the security and privacy that HTTPS provides. These days, you'll see ISPs, Comcast, for example, injecting modals and pop-ups and unencrypted connections, as well as there's captive portal concerns of users on public Wi-Fi. So deploying HTTPS, the end customer experience is much improved. Additionally, there's better performance, both from the fact that our servers are distributed around the world, and these data centers are much closer to the end users than your origin servers will be. So they're able to take advantage of that close TLS termination, as well as the optimizations back to your origin from those endpoints. So if it's transiting a large part of the world, we can take advantage of Argo, if that's a feature that is enabled for the account, and other performance optimizations that we use, such as Railgun, for example. Additionally, the HTTP2 protocol, while not mandated by the RFC, the only implementations of it are with TLS, so the browser needs TLS to actually advertise that it supports HTTP2 to the server. SEO for your end customer is pretty straightforward. So by serving it under their own domain name, there's better branding. The performance benefit from HTTPS helps SEO. Google will actually penalize sites without HTTPS, so they have a boost for those with it. And then, of course, the page load performance. There's a number of studies that indicate for every 1 second of delay, there's some percentage of lost conversions. And really the last benefit is simply they don't have to do anything. So if they're already pointing to you, there's nothing additional that they have to do for HTTPS reasons. And we're finding that's very, very attractive for these end customers. The benefits for you potentially as a SaaS provider, firstly is just providing that branded customer experience that your customers have come to expect. So when they're looking for a provider in your space, this is one of the things that we see people examining. So unless you don't have any competitors, your customers are going to be comparing you against the technical offerings that others provide, and more are going HTTPS by default. So in order to keep pace and remain competitive, both from a security and performance standpoint, HTTPS is a must these days. There's really no slowdown from an X-benefit perspective of onboarding. So we're seeing people implement this inline, and there's no out-of-band experience. We've talked to some prospective customers that takes multiple weeks for their support team to acquire and upload a certificate. So this really streamlines that process, removes that manual cost and effort and risk of handling that key material. Next is protecting your shared infrastructure. So we talked about this before of why do we see SaaS providers who already built some automation, why do they typically come to us? It's because the risk of being attacked and taking down all of those shared customers. So by using our SSL for SaaS provider solution, you are putting Cloudflare's network in front of your network, and we're able to absorb all of those attacks and prevent them from reaching your origin. You can use all of the features and benefits of Cloudflare from a security perspective as well. So rate limiting, all of the IP firewall and reputation, really anything that you can do in the dashboard, you can extend to your end customers. And lastly, just the risk around handling private keys. So oftentimes customers, if they're giving you a cert manually, they may give you a wildcard for their own domain. So that can be very risky. You really need to think about what policies and procedures you have in place to ensure that that's never sent unencrypted. Customers are notoriously bad at sending these via email or some other insecure fashion. And by using this solution, we'll only issue certificates for that specific host name, so there's no risk of that wildcard being exposed, and those keys never leave our network. In fact, they're never on disk in any sort of unencrypted fashion, encrypted in memory as they're generated.
All right, and that concludes today's presentation. We'd like to leave you with some resources for you to go check out more information about Cloudflare's SSL for SaaS solution. First is our industry solution information page. Learn more about how SSL for SaaS providers works under the hood. Our technical blog posting takes an even deeper look into Cloudflare's SSL for SaaS solution. And our white paper, SaaS Provider Survival Guide, Performance, Security, Encryption Essentials for Online Applications. Thank you everyone so much for joining us today, and always feel free to reach out with any questions that you may have.